In this video, I'm going to explain how layer 0, 1, and 2 networks work and how the real fundamentals work behind Bitcoin and Ethereum. In one of my previous videos, I explained how ISO 20022 works in about 5 minutes, and the video did really well. And I want to do the same thing now for the kind of network behind Bitcoin. I'm going to explain how layer 0, 1, and 2 works in 5 minutes. So think of the layers like this. Think of a bustling city network where people travel, trade goods, and build communities. Just like roads, highways, and express lanes that keep traffic moving, this is what these layers do, as well as using layered architecture to manage data. So think of layer 0, 1, and 2 as a massive infrastructure system, where each has a different role. First kind of package in this layering system is layer 0. Think of layer 0 as basically like the power grid that sits behind the whole network system. It basically has the main infrastructure that keeps everything on. It does stuff like it enables tokens and data to move securely between separate blockchains. It pools validators to protect multiple chains at once, so each individual chain doesn't have to build its own security from scratch, and it provides basically the rules and protocols for reaching agreement across all connected chains. And basically what it is it's the foundational network that connects the different blockchains. And that's what its main role is able to do. It works behind the whole system. Think of Polkadot, for example. That's a really good coin system which shows how layer 0 works. And what this does, it's basically the fundamental system that sits behind Bitcoin and Ethereum. Layer 1 is basically the DNA of Bitcoin, of Ethereum, and it's the whole network that actually sits in front, and the whole blockchain system. It's the proof of work and how everything works. Think of it in terms of city, like all the buildings, all the appliances, all the roads, and how everything that you see works. So some of the stuff it does is it includes transaction validation through nodes or miners who verify and record each transaction on the ledger system. Basically, every transaction needs proof that it happened properly to ensure that there's no kind of fraud on the system. It also is a consensus and security. As mentioned before, it's proof of work and proof of stake mechanisms to keep the network honest and tamper-proof. So, your layer 1 coins, you think of Bitcoin, Ethereum, Cardano, Solana, and Avalanche. And those blockchains each maintain their own rules, consensus methods, and security while tapping into the security grid, which is layer 0. Now, I saw this in another video and I thought it was a really good point. Layer 1s all have their different structures and their different rules, and they rely on these 3 things: scalability, security, and decentralization. And basically, you can't have all 3 of these. You need to have at least some kind of trade-off in one of these when using some kind of layer 1 system. So, for example, Bitcoin and Ethereum have the issue of scalability with limited number of transactions per second. But they've got that security and decentralization because they've got so much proof of work happening. Solana and Avalanche have that scalability and security, but they're not decentralized because they don't have as many nodes or validators making sure that the transactions are moving correctly. To give you an example, Solana has 1,000 active validators compared to Bitcoin's 15,000 and Ethereum's 4,000. Think of it like this: a small committee is able to do things quicker and they're able to vote on things faster. However, it means you're only relying on a small vote system, and it's more like a quote-unquote dictatorship. Not literally, but it's basically how it's structured. When you've got only a small amount of voices validating things, it means that you're relying on a certain group of people and it's more centralized. And then we have layer 2 systems. So the layer 2 systems work on top of layer 1 to solve that main issue of scalability. Remember what we were talking about with Bitcoin and Ethereum. So think about this like in the city, like increasing the number of lanes in a highway because there's so much congestion and traffic. To give you like a concept to understand, Bitcoin does about 7 transactions per second, while Visa, the system which we all use, uses about 24,000 transactions per second. And we need systems in this city to be able to run things faster. Run things like buses, like highways, like train lines to make things more direct so we can get our transactions done. And layer 2 refers to protocols built on top of blockchain's base layer 1 that offload transaction execution and then anchor the results back to layer 1. So it preserves the security of the base chain layer 1 while massively boosting throughput and slashing fees. So that solves the issue of scalability. So you can think of examples of that, like in Bitcoin, they have this system called the Lightning Network, which means that now they can transact at record speeds. And it means now that they're going from that 7 transactions per second to theoretically as much as 1 million transactions per second. However, we haven't seen that in full usage yet, and we can't prove that. We do know the speed is now there. So this is the final part, I guess, of a fast moving system, and it means now that we have everything working all together. You've got a grid to be able to make sure we've got power on the city, we've got all the infrastructure and buildings and appliances and cars, and then basically we've got the systems in place through layer 2 to be able to make sure everything moves fast. I hope that explains it. I tried to get it all done in 5 minutes. I think I've gone slightly over, but let me know how I went with this video. Thank you, and I hope you enjoyed.